Hi everyone, and welcome to this video on expanding. But this time what we're going to be doing is we're going to take this power, sorry I should have said expanding binomials, but it's not going to be a positive integer anymore. We're going to change it to things like fractions and negative integers, and you're going to see we're going to need a whole new formula. So what you're looking at here at the moment is basically what you already know. It's presented in a slightly different way. If you remember, I said the NCR can be written as NR. So that's what these are. But you can see the power of A is dropping down by 1 each time, and the power of B is also doing the same from the other direction. So B to the 0, B to the 1, B2, etc. But when we have a negative power or a fractional power, it basically doesn't work anymore. So we need to use a different version of the binomial expansion. And you don't have to worry yourself about where we got this from. You just need to know it. And it's going to look quite confusing at first. There it is. And you'll see the form is different, okay? So we have A plus B in the bracket, so that could be literally anything we want it to. That term plus another term, or minus a term, okay? But this power has to be positive. Now when the power is not positive, we're going to have to start with a 1 plus and then whatever we want it to be. Now what happens if it's not a 1? Well, that's for future videos, but today we're just going to look at some basic ones when it is a 1. Now here's the formula. So it starts off with a 1 plus nx plus n lots of n minus 1 all over 2 factorial. So that is the coefficient formula for the x squared term. And you can see the pattern now. It goes n minus 1 and n minus 2. And the next one will be n minus 3 as well, and n minus 4. And the factorial is also increasing by 1. So the x squared is 2 factorial, the x cubed is 3 factorial. And if you haven't used the factorial button before, it's on your calculator. I'll just see where it is on mine. Can't find it. Yeah, so it's above the x to the minus 1, you go up 1 from my bracket and then you have to press shift. Okay, to be honest, we don't often go past 3 factorial, so you don't need to use the button. That's why it took me so long to find it, because I don't use it. And there's this interesting statement down here about the expansion is only valid, okay? So that, you might be reading that and go, crikey, what on earth is that talking about? But the reason we do these often is to estimate values. So when we're trying to estimate, we only want an expansion that converges to a point. If each of these terms is getting bigger and bigger and bigger and bigger, we can't really use it as an estimate because it's just going further and further away. But if all of these terms are getting really, really small, especially by the 4th or 5th one, really tiny, they can be used to estimate answers to questions. Now, for it to get tiny and converge on a point, whatever this value is here has to be less than 1. If it is 1, they're all going to stay the same. If it's less than 1, when we start squaring and cubing and to the power of 4, to the power of 5, they just get smaller. Anything bigger than 1 obviously gets bigger and bigger and bigger. So this is a statement that you need to understand, that use of valid means it's converging. I don't like the whole valid thing. I want to say the expansion is converging when, and that makes a little bit more sense. So let's have a look at some questions. So what we do, obviously I can solve this one without the new formula because it's a positive integer as a power, but let's just get used to it. So I'm just going to write it out again. So 1 plus x to the power of n is equal to 1 plus nx plus n minus 1 over 2 factorial x squared. We want the first 4 terms, so there's the first 3, so we'll just pop this one on, hopefully it'll fit, yeah, just about. So that's the formula, really easy to remember. So let's go for it. So we've got 1 plus n, okay, so n we can see here is the power, so that's 4. Now, loads of people make the mistake here, they just put x. But what this x is representing, so in fact, I know the book puts an x, so I think it's better if it's an a, because then you don't automatically make this mistake, but what this is saying here, this x, is whatever that term is. So that and that are matching up. So whatever is in this place, you write for your x. So in this instance, I've actually got x over 3. So n was 4, n minus 1 is 3. 2 factorial is 2 times 1, so that's 2. And then we have x over 3 squared. So you'll notice I've been really careful here. I've got all my numerators on the same level and all my denominators on the same level. Really important. N is 4, n minus 1 is 3, n minus 2 is 2. Now 3 factorial is 3 times 2 times 1, which is 6. And then we have x over 3 cubed. So we want to be a bit crafty here where we can and try to cancel. So let's see what we can do. So this is just 4x over 3. We can't really do anything with that one. Now, lots of people make a mistake. They try and be too, try and cancel too early here, right? And they go, oh look, 3 there and 3 there, I can cross them off. But this isn't a 3 anymore because it's being squared. It's actually going to be a 9. But what you can see is, well, that is 12 divided by 2 is 6. So what I'm going to do is write 6 lots of x squared over 9. And then I'm going to cancel on the next line. Now here, I'm always looking out for this. So you can see that they're going to cancel. So I've got 4 lots of x cubed over 27. Sorry, I meant to hit the blue again, but I missed it. So you've got purple. So 6 divided by 6 obviously is 1, so they cancel. Okay, let's just tidy it up one last time. Go back to the blue pen. So you can divide both of these by 3, so you'd have 2x squared over 3. These don't cancel, so we're finished there. I've included them as a whole fraction. I could have written 4 over 3 and x. I could pull the coefficient in front and I could have written 2/3 of x squared. It doesn't honestly matter how you write it. I'm just going to put a plus dot 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 just to acknowledge there are more terms. Okay, and that's it. So if you did your normal expansion, you'll see you'll get the same answers. It's a pretty nice formula. So let's have a look at just these two. And we're going to go up to the x cubed term. And we're going to state the values for which the expansion is valid, which means it's converging towards a point. Let's just talk about that actually on this one. So what we're saying is whatever is being, so whatever this value is here, whatever the value is being to the power of 1, then to the power of 2, then to the power of 3, that has to be lower than 1. And these lines here means we're just looking at the positive values. It doesn't really matter what the sign is, so we're just going to look at the positive values, and that has to be less than 1. So therefore, the positive values of x have to be less than 3. Anything less than 3 means this sequence, or this expansion I should say, is going to converge to a point, and therefore be valid to use. Anything bigger than that, we're going to get values here that either stay the same, or they're going to get bigger and diverge. So if that's a bit confusing, don't worry, you've got plenty of time to get your head around that. Okay, so let's look at A. So we've got 1 minus x to the third. So let's do it. So we've got 1 plus nx plus, I'm going to just write the formula out again. It's a good habit to get into, especially when you're learning something new. Just write it up every time. And we've got to keep going until we get to, oh, stopped a bit short there, the x cubed term. Alright, so 1 is 1, we've got the first one, plus n, okay, n is a third, and x this time is minus x. When it's a minus, you've got to be extra careful. So n is a third, 1/3 take away 1 is minus 2/3. All over 2 times 1, 2 factorial is 2, and then we have minus, so I'm going to put that on the top as well actually. So we have minus x being squared. Okay, what do we have now? Third, minus 2/3, then we're taking another 1 away from that, so we're going to have minus 5/3. all over 6, that's 3 factorial, and then we have minus x cubed. Okay, so we've got 1 minus x over 3. First two are always pretty easy. Now, this is 2/9. I'm going to pop it up here. So 2/9, and we're dividing by 2. Or minus 2/9, okay, it doesn't matter, I can sort the sign out in a minute. So 2/9 divided by 2. Well, that's the same as 2/9 times by a half. And you can see what's going to happen is I can cancel these out to be 1s. So we actually end up with 1/9, or half of 2/9 obviously is 1/9. But we've got a positive and a negative, so we're actually going to get minus 1/9 of x squared. Yeah, this is going to be positive. Okay, what we're going to have here is a bit more complicated now. So we've got 10 over 27, and that's going to be divided by 6, which is the same as times in by 1/6. I can divide both of these by 2, so I'm going to get, well, what is that? I don't want to get that wrong. So 27 times 3, it's got to be 81, isn't it? Yeah, 81. So this is all going to be positive because these two negatives are going to make a positive. So we're going to end up with 5 over 81. Okay, so I have got that wrong. So scratch that. So this would be a positive. So we've got positive times positive. Obviously all that's going to be positive, but then we're going to get this negative in here because minus x all cubed is going to be a minus. Okay, so there you have the first 4 terms, which is basically the same as saying up to and including the x cubed term. So let's see if we can just shrink all of that down so it's not disappearing. Just get rid of that bit there because that's now annoying. And we'll try the next one. So b is presented to you slightly differently, but I'm hoping if you're watching this video you're pretty happy at this next step that I'm going to do. So that is the same as 1 plus 4x to the power of minus 2. When you have a power as a denominator, you can pull it up to the top, but it has to change sign. If you don't understand that, that's again a different video. Right, so the formula is already written up here, so I'm not going to write it again this time. So I've got 1 plus n. So my n is minus 2, that's my power, and my x is 4x. So n minus 1, lots of people write minus 1 here, just be careful, all over 2 factorial, which is 2, and then we have 4x squared. n minus 1, n minus 2, all over 3 factorial, which is 6, and then we have 4x cubed. Okay, so let's go for it. So we have 1 minus 8x, 6 divided by 2 is 3, and we're going to have 16x squared. Just take your time, don't try and go from here to the final answer. Too many people try it and fail. Okay, this is going to be a negative, you can see that. Minus 2 times minus 3 is 6, so basically we can ignore those now. So we're going to need to get rid of that plus. So it's going to be a minus, we can see that, and so it's minus 4 lots. 4 cubed is 64x cubed. So we've got 1 minus 8x plus 48x squared minus 256x cubed. And there you have it. So all we're going to do today is practice already written in this form, and then we can take it a bit further when we need to. Okay, hope that all makes sense, and best of luck.